Okay, in this question, they're giving you a lot of information to try and help you. So they're telling you in here that the copper sulfate that is hydrated is a blue colour. So here I'm going to put this underneath the equation so we can see it's blue. And then it says the anhydrous copper sulfate is white. So over here we have got white. And it says heat energy is needed to convert the hydrated to the anhydrous copper sulfate. So going that way, to make it go from the blue chemical to the white chemical, we need to heat this up. So describe how we can show this is reversible. So what we would do here is we would take this chemical and we'd heat it up, and then we'd see this chemical becoming white, and we'd see water vapor being released. Okay, once it's all gone completely white, what we would then do is add water to this, and this would then come back and become blue. And that's how we'd show it's reversible. So the three steps we've got: heat the blue copper sulfate until it goes white. Then you're going to add water, okay, and it'll go back to blue, and then you can repeat that process to show it's going forwards and backwards by heating or adding water. Next question, let's have a look. It's another reversible reaction one, so we've got to do some thinking here. So we're told that hydrogen reacts with iodine to form hydrogen iodide. And let's put some information in just to help us. It says the iodine gas is purple, so this gas here is purple, and the hydrogen iodide, so over here, is colourless. Okay, these are left in a sealed container, and the container is left until the equilibrium is reached. So that means that in the container we would have hydrogen present, iodine present, and hydrogen iodide present, because at equilibrium all three of those gases are present. The conditions are changed favouring the forward reaction, so they're making this go in that direction. Explain what you would see happening. So if I make this reaction go forwards, I'm actually going to have fewer iodine molecules in the sample. If I've got fewer iodine molecules in the sample, then this purple colour will start to fade, because it's going to become the hydrogen iodide, which is colourless. And that's all we've got to say to get the marks in this question. So we would say here, explain what you would see. You're going to see that the purple colour would start to fade. Okay, and then we've got to explain. So why is that going to fade? That's going to fade because there will be less I2 present as it is forming hydrogen iodide. Okay, so we've got 1 mark for saying what we would see, and then we've got a second mark for explaining why we would see that. Okay, next one. Calculate the number of atoms in 1 mole of copper iodide. Okay, so we've got a little triangle here to help us. So particles is moles times AC, AC being Avogadro's constant. And what we're going to do, first of all, let's have a think about this. We have got, if we're going to work out the, let's work out the amount of copper iodide inside this sample. So to do that, we're going to take, we want to work out the number of particles of the copper iodide. And to do that, according to this triangle, we will do moles times Avogadro's constant. So when we work out the particles, we do moles times AC. So the moles in this example is 1, because here we've only got 1 mole of this, and then we're going to times it by Avogadro's constant. Okay, and that's going to tell us that we have got 6.02 times 10 to the 23 of this copper iodide. But we've got to be careful. In copper iodide, 1 mole of copper iodide contains 3 moles of atoms. So why is that the case? That's the case because here you've got 1 lot of copper and you've got 2 lots of iodine. So in total, there are 3 moles of atoms inside 1 mole of this substance. So what I now need to do is take my answer that we've just worked out here, and we're going to multiply that by 3. So 6.02 to the power of 23 times it by 3, and that's going to give me 1.806 times by 10 to the power of 24, and now that is atoms. That's my final answer in that question. Marks wise, a mark in here for doing the multiply by 3, and then a mark for arriving at the final answer.